This question deals with the issue of reference cells. The reference cell, as far as your data book is concerned, is the hydrogen half cell. So the half reaction for hydrogen yields a 0 voltage. Well, I mean, all of the half reactions would yield a 0 voltage. It's just that when I was to put in a fluorine cathode and a hydrogen gas anode, then the voltage that would be produced is the 2.87 volts. And if I was to have the gold ion half reaction and the hydrogen half reaction, then the voltage produced would be the 1.5 volts. So these voltages are all assuming that these oxidizing agents are paired up with the hydrogen gas half reaction. When you come past the hydrogen, you start going down. The oxidizing agents now are suggesting that this is not a spontaneous reaction, and that is indicated by the negative signs in the electrical potentials. These are the voltages that would be required, or the minimum voltages that would be required in order to make the reaction between these oxidizing agents and the hydrogen gas. Where the hydrogen ion produces the hydrogen gas, if we have a hydrogen ion cathode and a hydrogen gas anode, we would expect no reaction to occur, and that's why it's 0 volts. If we were to change the reference half reaction to chlorine, the chlorine then would be 0. Now right now, chlorine is showing 1.36 because the chlorine gas is reacting with hydrogen gas. But if I was to change the reference cell to chlorine and assign the chlorine electrical potential in your data book as 0, that means I've had to actually subtract 1.36 to get 0. The question is asking, if that was the case then, if chlorine gas was 0, then what would be the new reduction potential for the copper half reaction? Well, in order to go from 1.36 to 0, I subtract 1.36. That's exactly what I do for the copper here. So, for the copper, it's 0.34 minus 1.36, negative 1.02. That would be the new reduction for potential for copper if chlorine was the reference half cell. So in other words, it would require at least 1.02 volts to force copper ions to react with chlorine ions. Copper react with chlorine ions. React with ions to, and the high react ones rise 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 to, and the high reactive 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 ones rise to, and the high